Hi everybody. Okay, so I'm in a different classroom today, and I know it's kind of dark around me, but I'm trying a couple things so that the video doesn't zoom in and zoom out. So hopefully this is going to help us. Okay, so you should be looking at your 10.4 Part 2 video notes, and it'll say at the top what you should be able to do thus far. Now, I know a bunch of you have been out this week and last week at different times, so if you don't feel comfortable with any of this, you need to get in to see me for extra help. But you should be able to find the distance between 2 points using the distance formula. You should be able to find the midpoint, that coordinate of the midpoint of a segment. And more importantly, you should be able to use those two things as well as slope to find the equation of a perpendicular bisector of a segment. At this point, you should be able to identify the equation of a circle, state its center and its radius, and graph it, and actually work backwards with all that. You need to be able to write an equation of a circle if I give you the center and the radius. You should also be able to write an equation of a tangent line to a circle. So if you're not feeling comfortable with any of these, you can go back to your video notes. I also have given you some problems at the bottom. And then last night's lesson, or a few nights ago's lesson, was talking about ellipses, okay? So somewhat like an oval. So you should be able to tell whether the major axis is horizontal or vertical, give me the vertices, give me the co-vertices, tell me about the foci, and graph it. And you should be able to write an equation at this point. Write an equation that has a center, if the ellipse has a center at 0, 0. Today we're going to do a little bit more with that, okay? But again, I gave you some problems that you can try in the book. You can go back to your videos at any time, and I want to make sure you guys are doing that, because that's going to be the important thing here with these video lessons, is that you're really taking the time in class to do your homework right when we're working in groups and asking the right questions, but also seeing me if something's not necessarily working for you, okay? All right, so let's move on. And we're going to talk about translating ellipses today, but I want to talk about what we did with circles first. So I give you a circle equation, x squared plus y squared equals 36, and we know that's in the form x minus h squared plus y minus k squared equals r squared, and my center is always hk, and remember it's change. But in this I don't have an hk, so that's telling me something. That's telling me that the center is 0, 0. My radius, well, 36 is r squared, so my radius would be the square root of that, which is the square root of 36, which is just 6. Okay, now this one's slightly different. We can tell my center. My center here would be 2, negative 4, because it's change sign, and my radius, again, would still be 6. So the circle size hasn't changed, but it has moved. It has moved to the right 2 and down 4, okay? That center point has moved down, to the right 2 and down 4. So that's going to be important, because we're going to be doing that with ellipses, and with ellipses it gets a little bit more challenging. But what I wanted you to notice is that it's just the same circle shifted. And in math we say translated. Right 2, down 4. And I use those terms a lot, okay? Okay. How do we graph that circle, okay? How do we graph it? Well, the first thing that you're always going to do is you're going to find your center, which was 2, negative 4. Then you're going to go and use your radius, and you're going to go 6 up, 6 down, 6 to the right, 6 to the left. So 1, 2, 3, 4, 5, 6. And I'm going to go down to that same point. And then I'm going to go 1, 2, 3, 4, 5, 6. And then I'm going to go up 6. So 1, 2, 3, 4, 5, 6. And then I'm going to go down 6. 1, 2, 3, 4, 5, 6. And I'm going to do my best job to make this a nice curve going through those points. And there's my circle with center right there. And I know it's slightly off. We don't want this to look like a square. We want it to look as much like a circle as we can, okay? All right, so let's move on to ellipses. So yesterday in class, we looked at an equation like this. X squared plus y squared x squared over 49 plus y squared over 4 equaled 1. That's an equation of an ellipse. I know it's an equation of ellipse because number one, I have an x squared over fractions. I have a plus in the middle, and it is equaling the number 1. An ellipse is something like an oval where I've got these 2 points called foci that are going to give me the same sum from any point on the oval. But I have to be able to tell whether it's horizontal or vertical. All right, so how do I do that? Well, I look at where the larger denominator is. And the larger denominator is under my x squared, so that's telling me that it's horizontal. But I do want you guys to consider something when you're doing this. And I know this isn't showing so great on the screen, but if I wasn't sure, okay, I look at the x squared over 49, okay, and I'll write it right here. Plus y squared over 4 equals 1. I'm going to graph my a's. So this is a squared, and it's under the x, so that means it's going to be on the x-axis. So that means I'm going to go to -7 and 7, okay? My b is under the y, and this is b squared, so my b is going to be 2, so it's going to go up 2 and then down 2. The major axis has to be the one that's larger, bigger than, major versus minor. So that's, I know, if I can graph these points, I've got my vertices and my co-vertices and my vertex of my ellipse. So I'm going to put those in. So I have 7, 0, -7, 0. My co-vertices are going to be the flip because they're on the y. So 0, 2, 0, -2. Okay, but what's the center? And I don't know that I spent a lot of time talking about this yesterday, and so I apologize for that, but now I want you to look at it. Just like the circle, if there's no number in here, then the center is 0, 0. Okay? All right, now we've got to find our foci. So I told you yesterday that it was very easy to find your foci using c squared equals a squared minus b squared. I want you to be very careful. It looks like the Pythagorean theorem, but it's not, okay? Because there's a minus in the middle. All right, so we plug in the values we have. We know our a squared is 49. We know our b squared is 4. So we get c squared equals 45. We solve, and we get c equals root 45. And I would reduce this. The largest perfect square in 45 is 9. So c equals 3 root 5. Now, I would actually take a minute and want you to think about where that might be on a number line. I know that it's got to be somewhere between 6 and 7 because the square root of 36 is 6, the square root of 49 is 7. If you use your calculator, it works out to be 6.7. Round it, okay? Now, the foci has to lie on the major axis. So that means it's going to be right about here, and I'm going to say -3 root 5, and I'm going to say right here, +3 root 5, okay? And I'm just going to put focus here for me, okay? Now, if I ask you for the focus, I do really want a coordinate point. So at this point, once you've got it on your graph, you can write your coordinate point as 3 root 5, 0, and -3 root 5, 0, okay? And then we'll go ahead and we will graph our ellipse, connecting all of our vertices. It's not looking so good on here, so I apologize. And it looks something like that, okay? All right, so today what we're going to do though, that's all stuff we did yesterday. Today what we're going to do is we're going to look at the same graph, same ellipse, but we're moving the center, okay? So again, we do the same thing. We identify whether it's horizontal or vertical, and it's still horizontal because the denominator of the x squared is larger, so it's horizontal, okay? My center, okay, my center, just like the circle, my center is inside, it's H and K, and it's change. So my center here is going to be 3, 9, okay? All right, my vertices. Now this is where there's several ways to do this, but I think it's easier by using the graph, okay? So we're going to go to our graph, I'm going to try and make a really nice big graph, and this is going to be kind of hard for us to see. Actually, you know what? I'm going to go to a new page. So let me get a new page. So I'm going to do this. I've got my graph now, and I'll rewrite my equation. X minus 3 squared over 49 plus y minus 9 squared over 4 equals 1. Okay? All right. So the first thing I'm going to do is take my center of 3, 9. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to mark it. Okay? 3, 9. And I might even put a center right there for myself, okay? Then I'm going to talk about my A and my B. I know already that my A squared is 49, so my A is 7. So that means I'm going from the center, I'm going to the left 7 and to the right 7. So from here, to get my vertices, I'm going to go 7 this way. 1, 2, 5, 6, 7, and then still up to 9. So that coordinate is going to be 10, 9, and I'm going to go 7 this direction. So I'm already at 3, so I'm going 1, 2, 3, 4 here. So I'm going to be at negative 4, 9. Okay? And that's my major axis, so those are my vertices. Now I've got to use my co-vertices, okay? My co-vertices are my B, which is B, this is B squared, so my B is 2. So I'm going to go up 2, and so if I'm going up 2 from 9, I'm going to be at 11. So that coordinate point would be 3, 11, and I'm going to go down 2, so 1, 2. So that coordinate point would be, let's see right here, that coordinate point would be 3, 7. So I'm not going to go back to the chart, but you guys can put it in here. We've got our vertices, and we got our co-vertices, okay? So my vertices then would be 10, 9, and negative 4, 9, and my co-vertices would be 3, 7, and 3, 11, okay? All right, so let's actually look at another example, okay? All right, so x plus 3 squared over 64, y minus 5 squared over 36. Okay, so I look at it and I have to identify, is it horizontal or vertical? The x squared is larger, the denominator of the x squared is larger, so it's horizontal, okay? I'm going to identify my center right off the bat. My center here would be negative 3, 5, okay? So now I've got to find my vertices, my co-vertices, and my foci, and I just realized I didn't do the foci in the last one, so I'll go back to that in a second. We'll practice it on this one. So I'm going to draw my graph for myself to make this easy. And again, this isn't the only way to do this. I just like looking at a picture of it because it helps to kind of move around. All right, so I'm going to plot my center at negative 3, 5. Okay, so negative 3, 5. Okay, and then my vertices I know is going to be my A's. I'm going to be going A away in each direction, and since A squared is 64, I know that my A is equal to, and I'll write it right here, is equal to 8. So I'm going to go 8 to the right and 8 to the left because it's horizontal, okay? So if I go 8 from negative 3, I'm going to go to 1, 2, 5. So right here, so my coordinate there would be 5, 5, and I'm going to go 8 to the left, which is going to put me at 8, 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to be at negative 11, 5. Okay? So it's really just counting. So I'm going to put those points in. Negative 11, 5, and 5, 5. Now I'm going to go to my co-vertices. So from my center point, I'm going to go B. And my B squared is 36, so my B is 6. So I'm going to go up 6, down 6. So from 5, I'm going to go up 6. 1, 2, 3, 4, 5, 6. So I'm going to be at the point negative 3, 11, and I'm going to go down 6. So 1, 2, 3, 4, 5, 6. So I'm going to be at negative 3, negative 1. Did I do that right? Okay. So now our foci is still we still are gonna do, okay, so let's put our co-vertices at -3, 11, and -3, -1. And our foci now is still c squared equals a squared minus b squared. All right, so c squared equals 64 minus 36. So c squared equals, what did I get, 28. So I approximated c to be about, first of all, 2√7, which is approximately 5.29. So that means I'm going to go on my horizontal axis. I'm going to go 5.29 this direction and 5.29 this direction. So that's going to get me at about, did I do that right? Yeah, it's going to get me about 2.35 for one, right about there, and the other one's going to be at -8.35, so right about there. Okay, so those are my foci. And then I'm going to connect all my vertices in a nice ellipse. And that one's a lot better, okay? All right, so we're gonna do one more. All right, and actually, how we did that time? Okay, so the last one I just want us to do, we're not gonna graph it, let's just get all of our information down and then we'll graph it tomorrow in class. So first of all, is it horizontal or vertical? Giving you a second. It's horizontal, good. My center is at the point. Hopefully you're saying 0, -2. Okay, I am going to graph it because that's how I'm having you do it. All right, so I'm going to go to the point 0, -2. I just did, there we go, so 0, -2. And then I'm going to go, my a squared is 25, so my a is 5, so I'm going to go 5 in each direction, 2, 3. So I'm going to go 5 here, and 1, 2, 3, 4. I did one too many. Those points right there would be -5, 2, and 5, 2. So there's my vertices. My co-vertices would be my b squared is 16, so b is 4. So I'm going to go up 1, 2, 3, 4 to right there, and down 4, 1, 2, 3, 4 to right there. Those points then would be 0, let's see, 0, -6, and 0, 2, if I got that right. To do my foci is going to be c squared equals 25 minus 16, c squared equals 9, so c equals plus or minus 3. All right, so that means I'm going to go from here, I'm going to go along the horizontal, 1, 2, 3, and 1, 2, 3. So those points would then be 3, 2, or 3, -2, and -3, -2. Okay? All right, so I want you to bring these notes tomorrow, and we're going to review this some more, and we're going to practice everything we've learned so far in class tomorrow. So have a great night.